Okay. So I'll be presenting on boreholes and smart irrigation. So the first thing, when you want to drill a bore, there is what we call a statutory requirement. You have to go to local authority or to local authority and a catchment council. This is where you are given a permit for you to drill a bore. So after that, when you go to catchment council, they will need what we call a site survey. So you first conduct what we call a bore survey, the bore site survey. So you bring that survey to catchment council, and then they will give you a permit for you to drill a bore. They will tell you whether you can proceed to drill your bore or you are not. So they will use that survey report for you to register, and you pay a certain fee, which is $100 per year. Then on bore surveys, there's what we call traditional bore techniques and geo scanning techniques. So on survey, we usually recommend, as for us, we do both of them. We do traditional and the new technology of using Zero Detect and PQWD's machines. So I just want to make it clear that as of now, we do not have a machine which can detect water in terms of depth 100%. We do not have that machine. All the machines which that we have, they have starting from 80% to 90%. Let's say 90%. That's the maximum. So all the machines, what they do, they will detect what we call breaks or underground streams. So it depends with the location. So some of the machines are very good in some areas, and in others they are not well good because we have variations in terms of soils and geoformation. So we'll try by all means to use different machines for you to continue to drill your bore. Yes. So as I said, you get your permit. After getting your permit, this is where you can proceed. On drilling bores, we recommend that the payment should be paid on site to avoid some complications. And I will just explain some of the terms which are familiar in bores. And those terms are what we call partial casing, double casing, and full casing. So we have two types of bores. In bores, we have two different drilling bits, which are 9.5 inch and 6.5 inch. So at first 20 meters, we use 9.5 inch, which is a clay cutter bit. Then after that, we use the 6.5 inch. So on casing, there's what we call partial casing and full casing. So all those terms depend on the formation of the ground. Partial casing usually used when there is a hard rock beneath. So there's no need for us to do full casing. Or partial casing can also be used when the bore recharge is not that much high. So if you do full casing, it means we are preventing the some of the slots, what we call underground streams. So when the bore recharge is very low, we usually recommend the partial casing so that the water will freely move into the hole. And also when there is silt formation, the silt, if we do full casing on the bore which has a lot of silt, the silt will accumulate outside the casing, and it also block the slots which I've already mentioned, which so that your bore will end up having what you call a low recharge. So the advantages of partial casing is that you can also deepen the bore in long run. If you want to deepen your bore, there's no need for you to do a full casing, because it will need a special what you call a special rods, special bits for deepening, which are not familiar, especially here in Zimbabwe, those bits. So if you know that you want to deepen your bore, you need to use to do partial casing so that the deepening process will be much easier. Then the disadvantage of full casing, it needs a full analysis of the profile, so that maybe in long run the bore it can collapse, because the rocks underneath can move, because the bore is not much fully cast. So usually we much recommend, if the recharge of the bore is good, we much recommend full casing, because you have a guarantee that your bore is very stable, right? I think I've explained much on that. Then on the issue of double casing, I think you have heard something like double casing, double casing. It's not something which you can plan before, so that I will need my bore to be double cased. It's not like that. It will depend on the situation on the ground. For example, double casing is used, it can be done when there is loose formation on top horizons, which can cause the bore to collapse during the process of drilling. Or we can also have what we call surface water. Surface water can also disturb the process of drilling, so the bore need to be double cased on the top horizons. Usually it's 12 meters, not more than 12 meters. So if the top horizons is very loose, we need a double casing, so that some of the stones and other even water cannot go into the hole and end up enlarging the diameter of the hole. So it will need to be double cased, right? I think I've explained much on double casing. Then after drilling a bore, we recommend what we call capacity testing. Capacity testing is where we are trying to know the recharge capacity of the bore, patinoti kudzinira kwemvura kuya kuya. Saka recharge capacity inotibatsira kuti number one, it will help us to size a pump, because we will need a pump which has a discharge which is slightly lower than the recharge of the bore, so that your bore will not dry up during pumping. So we need a pump which has a discharge which is slightly lower than the recharge of that bore. So we will need that report. It's much important to know the recharge capacity of your bore. So those results can be obtained from what we call a capacity testing process. So from that capacity testing process, we also need to know what we call irrigable area. If you want to use that bore for commercial use, let's say for irrigation, you know that maybe per day I can have 20,000 liters. So you can relate it to your irrigable area, to your land which you want to irrigate. If it is that water enough to irrigate maybe per day, or maybe you want to use that water for watering animals or even for potable water. So it's much important for you to do what we call capacity testing. Then from that, I think I've explained much on both. Let me move into smart irrigation. So let's say that now you have your source of water. You now have your bore. So you want to use that bore for commercial use. You want to use it for irrigation. So for irrigation, we have different types of irrigation. We have drip irrigation. We have surface irrigation systems. We have center pivots, overhead irrigation systems. We have micro irrigation systems. So I will just pay much for today. I will pay much attention on drip irrigation. So on drip irrigation, I think much of us are familiar with that. It's a system which can irrigate a quite number of crops through droplets, or what we call trickle. So that system saves much water and is very much efficient, and it has high uniformity. So in drip irrigation, we are now currently working on something which is, I think, much of you are familiar with that. It's surface, we call it a subsurface irrigation system. Subsurface irrigation system. So this system is where what we call drip laterals are buried underneath for a depth of 15 centimeters. So this system was developed to reduce evaporation and also to increase what we call precision irrigation, because the water is supplied directly to where it is needed, to the roots. So it's what we call a subsurface irrigation system. I think I am done on